Okay, let's look at question 1b. Use a left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. Okay, so what do we need to do here? Well, the first thing is we need to remember what a left Riemann sum means. So if we look over here at our notes, and this is from page 165, we see that we have what a left Riemann sum means. So the left Riemann sum means we start from the left and we extend out till we do our next interval, and then we extend out to our next interval, and then we extend out into our next interval until we extend out. And that's essentially it. So that's essentially it. Then in this problem, what I want to do is I'm going to actually plot points to give you an idea of what this graph looks like with these points, and then we can examine what happens when we do a left Riemann sum. Now, one thing I want to stress here when we plot these points, on the actual AP, doing this, if you have to do this, go ahead and do it. But very often is the case, doing this is going to eat up your time, and so if you can, once you understand this idea, you just need to implement it. You don't need to do this. But initially I want to give you an idea of how to get started with this. So we're going to start at 0, 1340, there's 0, 1340. 0, 1340. Then let's say that this one here is going to be 1, give myself a little space here, 1 and what is it, 1190. 1190. And then let's say that this is 3, and it's 9, let's say this is 950. And then we'll argue that this is 6, and this is going to be 740. So we'll say it's 6 and 740. And then we'll argue that this is 8 right here, and then this is 700. Okay? Doesn't have to be incredibly accurate, just to give you an idea of what's going on here. So we have this right here. Right? And we're drawing left Riemann sum. So let's go back here and notice that we start, what I said is I start at the point, first point, and I extend out for the interval. Okay? So my first one is going to start here, and we're going to extend out till we get to the end of the interval, which is at 1, and this is going to be my first Riemann sum. Then we're going to do the same thing over here. We're going to extend it out till the interval ends. Then we're going to do it again here. We're going to extend out till the interval ends. Then we're going to do it again here. Extend out till the interval ends, and then that's it. So what did we really do? Well, if we take this picture here, what we did was we found the difference between these points, right? And that's going to go with 1340. So what am I saying here? The difference between here is 1, and then we're going to multiply that by the height, which is the first value, 1340. And then we go again. So we take the difference of the interval, 2, and we multiply by its height, 1190. The difference of the interval here is 2, and then we multiply that by the height, 1190. Okay? Then we take the next interval. Now you're starting to see the pattern, hopefully. That's 3. Difference is 3. By the height of the third one, 950. So we're going to take plus the difference here, which is 3 times the height, which did I not write that? 950. That's it, 950. Sorry, 950. And then we just keep going. So the next one's going to be what? The difference here, which is 2. What's the height? 740. This difference here, 2. What's the height? 740. Okay? And so if we add all of these up, that gives me my answer. And if I do this correctly, I get 80, 50. 80, 50 what? What are these? Well, if you're multiplying liters per hour by hours, for multiplying liters per hour by hours, what am I getting? Well, the hours are going to cancel, and we're left with liters. So we're getting liters. Okay? And so this is going to be equal to 8050 liters. So what in essence am I saying? Well, okay, if I'm taking the interval, right? I'm finding the Riemann sum under in here, right? Under the curve by using these rectangles. So what I'm doing is I'm integrating from 0 to 8, right? Integration is just the area under the curve. RT with respect to time dt. And so what does that mean? That means I'm doing 1 times R0 plus 2 times R1 plus 3 times R3 plus 2 times R6. Squeeze it in there. Okay. Right? What am I saying? That's 1, that's R1. That's 2, that's R2. That's 3, that's R3. That's 4. That's 2, that's R4. Or I'm sorry, R6. So this value here corresponds to this. This value here corresponds to this. This value here corresponds to this. And this value here corresponds to that. Okay? Obviously, if the numbers are 1, 2, 3, 2, here we have 1, 2, 3, 2. Okay? Why? Because what does R0 mean? That's the Y value, right? The Y value at each place. 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 Also note, we do not, if it's a left, we did not use 700. That's very important, okay? And as you recall, we did a lot of problems in the past. That's supposed to be 1 there. We did a lot of problems in the past in regard to this. You've had lots of quizzes over this. So hopefully that makes sense. And your answer here is 8050. I'll see you all in 1C.